Hello everyone, welcome back again to our math tutorial video. And for today, we will be talking about applications of first order differential equation, particularly the Newton's law of cooling and the laws of growth and decay. The applications of first order differential equation involving Newton's law of cooling and laws of growth and decay. So applications of first-order differential equation consist of Newton's law of cooling, laws of growth and decay, and orthogonal trajectories. But for now, we will be discussing about Newton's law of cooling and laws of growth and decay. First is the Newton's law of cooling. So it states that the rate at which a body cools is proportional to the difference between the temperature of the body or substance and that of the medium. And if we will express that one into mathematically, so we have here the derivative of a capital letter T with respect to small letter t is equal to k times the quantity of T minus T sub m, where the capital letter T is the temperature of the substance or body, and small letter t is time, k is the proportionality constant, and T sub m is the temperature of the medium. And through the use of rate of equation or this equation, we can derive the general solution that can be used to solve a certain real life problem. So T is equal to T sub m plus C times e raised to kt, and that is our general solution. And the next slide I will be discussing about the process of how can we derive the solution or the general solution using this equation. We have here an example. An 80 degrees Celsius warm bowl of oatmeal is placed in a room with a temperature of 20 degrees Celsius. After 2 minutes, it gets 60 degrees Celsius. How many minutes it will take to cool to 40 degrees Celsius? So, using the rate equation or the derivative of the with respect to time is equal to negative k times t minus T sub m. So you may ask why we have a negative equation here. So since we are talking about the decrease of temperature, so we have this kind of equation. So note that if the temperature of the body or substance is larger than the temperature of the room, it is expected that the temperature will decrease. Thus, we have a negative rate of change here. And on the other hand, if our temperature is lower than the ambient temperature, so then this is going to be negative. So, T minus T sub m. So, since we are talking about our substance is warming up, so that's why a negative of a negative will give us a positive. And now, let's use this equation to arrive on our general solution. And we will divide both sides by 1 over t minus t sub m. So we have 1 over t minus t sub m dt is equal to negative k dt. So we will integrate both sides, and the integral of 1 over t minus t sub m is going to be the natural logarithm of the absolute value. So we have ln absolute value of t minus t sub m is equal to kt plus c. And we can raise e to both of these powers, or we will exponentiate. So we have absolute value of t minus t sub m is equal to e raised to negative k t plus c. So note that e raised to negative kt plus c is just the same thing as e raised to negative kt times e raised to c, where e raised to c is equal to c. So it is loss of exponents. So since our absolute value is going to be positive, so we can add t sub m to both sides. So we have t is equal to t sub m plus c e raised to negative kt, and that is our general solution. So since we already get our general solution, we will use this one to find the answer of the given problem. Okay, first thing is we will identify the given values in the problem. So we have here the temperature of the body or substance is 80 degrees Celsius, and the temperature of the medium is equal to 20 degrees Celsius, and our time is 0. So we have here the solution, and by using our general solution, which is the Newton's law of cooling, so we'll plug in all the values. We have 80 as our temperature of the body is equal to 20 as our temperature of the medium plus c e times e raised to negative k times 0, which is our time. So by using the addition property of equality, we have 80 minus 20 is equal to c times e raised to negative k times o. Note that negative k times 0 is 0, and e raised to 0 is equal to 1. So we have the equation 60 is equal to c, and that is the value of our c. So now, to find the value of k, we will plug in the value of c and the values of the second condition in the given problem. So the given values in the second condition of the problem is T is equal to 60 degrees, which is our temperature of the substance or the body, and our temperature of the medium is 20 degrees Celsius, and our T is equal to 2, and C is 60 degrees Celsius. So we have here plugging all the values. So we have 60 as our T is equal to 20 as our T sub m plus 60 e raised to negative k times 2. So we can rewrite that e raised to negative 2k. So we have 60 minus 20 is equal to 60 e raised to negative 2k form by using the addition property of equality. Now, we will do the math. So 40 is equal to 60 e raised to negative 2k. And now, to eliminate 60 in the right side of our equation, so we will divide both sides by 60. So, giving us 40 divided by 60, we have 2/3 is equal to e raised to negative 2k. And to eliminate e, we will use the laws of logarithm. So we have ln 2/3 is equal to ln e raised to negative 2k, and e will be cancelled out. So we have ln 2/3 is equal to negative 2k, and for us to identify the value of k, we will divide both sides by negative 2. So we have k is equal to 1/2 ln 2/3. Now, since we already identify the values of c and k, we will plug in these values to find the answer or the solution of the main problem in the question here, the first question. So the given are T is equal to 40 degrees Celsius, and our temperature of the medium still the same, 20 degrees Celsius. Our C is 60 degrees Celsius. Our K is 1/2 times ln 2/3, and our T is the unknown. So our solution here, using the Newton's law of cooling, so we will plug in all the values. So we have 40 as our temperature of the body or substance is equal to 20 as our T sub m, plus our C is equal to 60, e raised to rk, which is 1/2 times ln 2/3 times time. So, using the addition property of equality, we can have this equation: 40 minus 20 is equal to 60 e raised to 1/2 times ln 2/3 times t. And we will do the math here. So we have 20 is equal to 60 e raised to 1/2 ln 2/3 times t. So to eliminate 60 on the right side of our equation, so we will divide both sides by 60. So we have 20 divided by 60, we have 1/3. So the lowest term of it is 1/3. So is equal to e raised to 1/2 times ln 2/3 times t. And using the laws of logarithm to eliminate e, so we do this to eliminate e. So using the laws of logarithm, we have ln 1/3 is equal to 1/2 times ln 2/3 times t. And we will divide both sides by 1/2 ln 2/3 to find the value of t. So we have the equation t is equal to 2 ln 1/3 over ln 2/3, and by using our calculator, we can have the value of t, which is approximately 5.42 minutes. So therefore, when an 80 degrees Celsius warm bowl of oatmeal is placed in a room with a temperature of 20 degrees Celsius, it will take 5.42 minutes to cool to 40 degrees Celsius. And now let's proceed to the laws of growth and decay. So it states that the rate at which the substance changes is proportional to the quantity of substance present at any time. So if we will express that one to mathematically, we have the derivative of x with respect to t is equal to kx, where x is the quantity of substance present at any time, and t is our time, k is the proportionality constant. And by using again this equation, we can derive our general solution. So next slide, we will be talking about that one. So we have here the application. The population of a city increases at a rate proportional to the current population. In 2015, the population was 1.79 million, and in 2019, the population was 2 million. What is the predicted population in 2030? So first thing, we will derive our general solution here using our equation, which is the derivative of x with respect to t is equal to kx. And next is, we will integrate both sides, having the equation ln x is equal to kt plus c. And exponentiate both sides, so we have e raised to ln x is equal to e raised to kt plus c. And note that e raised to kt plus c is just the same thing as e raised to kt times e raised to c, and e raised to c is just equal to c. So we will eliminate the e ln and x. So we have here the equation x is equal to e raised to kt plus c. So as what I have said, e raised to kt times e raised to c is just the same to e raised to kt plus c. The application of laws of exponents here. So we have here the equation x is equal to c e raised to kt. So I just rewrite that one. So we have here the general solution. And yes, since we already have the general solution, we will now go to the solving of the given problem. Okay. So first, we will identify the given values. We have x So the population is 1.79 million and RT is 0. So using the formula we have derived a while ago, so we will plug in all the values. So we have x as 1.79 is equal to c e raised to k times 0, which is our time. And e raised to k times 0 is just 0, and e raised to 0 is equal to 1. So we have 1.79 is equal to c times 1, and rc is equal to 1.79 million. And to find the value of k, we will plug in the value of c and the given value of the second condition of the problem. So we have here the given x is equal to 2 million and RT is 4. Since 2019 minus 2015, we have 4 years. And RC is equal to 1.79 million. Now we will plug in all the values using our formula. So we have here 2 as our x is equal to 1.79 as RC times e raised to k times 4, which is our time. So to eliminate 1.79 on the right side of our equation, we will divide both sides by 1.79. So 1.79 will be cancelled out, and we have 2 over 1.79 is equal to e raised to 4k. And by using the laws of logarithm, we can eliminate e on the right side of our equation. So we have ln 2 over 1.79 is equal to ln e raised to 4k. So this will be cancelled out, and leaving as ln 2 over 1.79 is equal to 4k. And to eliminate 4 on the right side of our equation, we will divide both sides by 4. So we have rk equal to 0.0277. And since we already have the values of c and k, we will now go to the main problem of the given question. So we will identify first again the given values. So we have x as our unknown and t as 15 years since 2013 minus 2015, so 15 years. And RC is 1.79. So solution using the formula we have, so we will plug in all the values. So since x is our unknown here, so we have x is equal to c, which is 1.79 e raised to k. Our k is 0.0277 times 15, which is our time. So we have, by using our calculator, so we have x is equal to 2.71 million, or we can round it up to 3 million since there is no decimal people. So that is our answer. So therefore, the predicted population on 2030 is 3 million. And that's it for this video. I hope you learned something, and see you on my next uploads.